All right, good afternoon. Let's get started. Thank you to everyone who's tuned into our webinar. We appreciate you taking the time out of your busy day to join us to discuss effective inventory management and traceability using TrakSYS and RFID. As questions come up today, please enter them into the webinar console. We'll be taking time at the end to address those questions that make sense to answer in a group setting. And all questions will be addressed after the broadcast and emailed out along with a link to the recording of this webinar. I'm your moderator, Corey Budvarka, and I'm joined today by Tim Smith, Senior Industrial Engineer with Hydronautics, a NITO Group company. Tim's career in semiconductor and environmental services industry has been focused on driving projects to maximize efficiencies in production processes, reduce operating costs, and implementing automated systems for real-time shop floor control, data collection, and reporting. His most recent accomplishments at Hydronautics have included the design and implementation of a new manufacturing execution system, and implementing RFID technology on the production floor for traceability, inventory management, and maintaining critical product data that supports Hydronautics' initiative to leverage IoT throughout the company. Tim earned his MBA at Arizona State University W.P. Carey School of Business and his Lean Six Sigma Master Black Belt certification from Villanova University. Also joining us is Jim Flagg, Smart Manufacturing System Architect with Polytron. Jim has over 25 years of experience working on controls and manufacturing intelligence projects. After graduating from Georgia Tech, Jim began his career designing and programming PLC-based control systems for a diverse range of customers. When software became available to use PCs on the plant floor, Jim's projects first used them as HMIs and then expanded more complete data collection and reporting tools. For the last 12 years, Jim is focused on connecting the plant floor with ERP systems in multiple MES projects. Since 2004, Jim has been the lead technical engineer for Polytron's manufacturing intelligence projects. In this position, he has consulted with multiple clients to develop their overall software and hardware architecture that will provide plant floor data in convenient ways to plant personnel. Most of these projects involve working with the customer to develop a user requirement specification, which outlines how the project will meet their current and future data collection, reporting, and ERP interface needs. To quickly bring you up to speed on who Parsec is, we've been in the business for 30 years, with a dedicated focus exclusively on developing manufacturing operations management software, which you'll hear us abbreviate MOM. Our TrakSYS solution platform is designed to measurably help our customers without the need for disruption or major infrastructure overhaul. TrakSYS has been deployed in thousands of locations in over 100 different countries. We've helped customers in a variety of industries like food and beverage, pharmaceutical, CPG, and aerospace, just to name a few, to significantly improve their manufacturing operations. So Tim, can you tell us a little bit about Hydronautics?
Sure. Hydronautics is one of the global leaders in the field of integrated membrane solutions. And we operate our manufacturing facility here in San Diego, California. Hydronautics produces a wide range of water filtration products like reverse osmosis, nanofiltration, microfiltration for large wastewater treatment plants, desalination plants for seawater, industrial process water treatment, as well as many specialty treatment applications around the world. So Hydronautics was acquired back in 1987 by Japan's NITO Denko Corporation. So we're part of NITO's global membrane division with 3 manufacturing locations, ours here in San Diego, as well as a plant in Shiga, Japan, and Shanghai, China. If you think about the small round RO filters you have under your kitchen sink, to generate drinking water. We basically produce similar products in our factory, except ours are much larger. They weigh about 35, 40 pounds each. And our filters, they're about 4 inches to 16 inches in diameter, 4 feet long, and they're connected in large filter banks within each plant. I think it's an exciting industry since we're basically in the business of making products which take non-usable water and turn them into pure drinking water.
That's great. Thanks, Tim. And Jim, can you tell us a little bit about Polytron?
Sure. Thank you, Corey. Polytron has been delivering best-in-class manufacturing solutions for over 35 years across multiple industries. Our Smart Manufacturing Group specializes in helping manufacturers develop and implement their digital transformation strategies and roadmap with a focus on delivering incremental, measurable business value along the way. Polytron has been a Parsec partner for over 10 years, delivering TrakSYS-based solutions for many manufacturers during this time.
So to start things off, Tim, can you describe the high-level business drivers for the project at Hydronautics?
Yeah, thanks, Corey. I think when we first started looking at implementing our RFID strategy here at the plant, we pretty much focused on its application in 3 primary areas. First, within our manufacturing operations. Second was in our warehouse and distribution processes. And finally, the deployment of RFID technology to our external customers. So one of the primary drivers for this project was the opportunity for us to decrease production costs, specifically in our direct labor costs. The ROI justification for most of our projects includes savings in this area. So it was a key factor in this project as well. Another critical driver for us was launching this product with the ability to increase production efficiency within our manufacturing processes. So we've made significant investments in automation projects to streamline our workflow. So it was important that the project contributed to increasing the efficiency in our manufacturing operations. Improving distribution efficiency was another driving factor for us. Since we ship our products around the world, we spend a significant amount of time managing our large warehouse and picking products to fit specific customer orders. So having the opportunity to streamline this process and respond quicker to our customer requests played a big role in the success of our business, and it needed to be kind of a factor in this project as well. Another key business driver for us has been NITO's direction in the past couple of years to leveraging IoT into products that we deliver to our customers. And RFID technology will certainly allow us to create a better IoT compatible product for our customers. And finally, one of the leading factors driving RFID in the future involves interface with our ERP system and expanding the integration of RFID into the business process that we run all around our organization in the world. So this is has been a launch for us into putting a technology in place in our factory, which hopefully the visibility will allow us to open up other opportunities to utilize RFID in the rest of the organization.
So I understand you were operating with several different disparate systems. Can you describe the existing systems that were in place before the TrakSYS project was implemented?
Sure. At Hydronautics, we run our enterprise resource planning system on Oracle's JD Edwards ERP platform. We produce about 1,000 filter elements a day, and each filter element is assigned a unique serial number for tracking purposes at the beginning of the process. So before this project, the only form of tracking involved barcode labels, which we printed on and attached them to each of our filters at the beginning of the process. So the barcode labels get scanned several times within our production process. And at the end of the production process, 100% of our elements are produced and undergo performance testing. So each individual element has its own unique characteristics measured during what we call our wet testing process. At the end, the data is entered into a specific database, and JD Edwards holds each filter detail, including performance test results and history. So before this project, the only way we could access this data was to log into our ERP system and run specific queries or reports to get the data out of the system into our hands for evaluation.
So Tim, can you tell us about some of the challenges you were experiencing in the operation?
Sure. As far as, if you look at this illustration, the picture on the left, this is a batch of 16 elements, which we transport on a large rolling cart. Each of these elements has its own individual barcode label for tracking. But as you can see, it's very difficult to reach inside the cart and scan each of the individual 16 barcode labels. And similarly, the picture on the right side of the slide you're looking at, which shows our factory floor, looks like, well, there's thousands of filter elements. When we're performing our semi-annual inventory count, each of these elements has its own barcode label, as I mentioned, which needs to be scanned. We have to scan them one at a time. So the process of going through this twice a year is extremely time consuming, and it took several hundred man hours and a couple of days, often 1 or 2 days to complete. So one of the biggest limitations of the barcode system is the elements need to be oriented in a specific direction for barcode reading. So this significantly reduces production efficiency since operators need to continually rotate or reposition elements to get the barcode in the position for reading the tag. In addition, barcode readers can only read one filter at a time. So this makes the process of taking inventory counts extremely labor intensive, and you can see the volumes that we had there on the floor. All the non-value added waste in motion and material handling highlighted the fact that barcode reading was just too time consuming for us. Additional limitations to the barcode system in our situation is that when we have work order changes or product type changes in our element, barcodes have to be reprinted or updated with specific data. Another issue is the lack of durability. Barcode labels, even the slightest physical damage to them make them no longer readable, and we have to produce or reprint the barcode labels. You can see in the factory the large elements get handled quite a bit. And another one, the barcodes themselves carry very little information, which is static. So the use of barcodes made leveraging IoT difficult.
So despite the limitations, it sounds like the barcode system served Hydronautics pretty well for many years, but they saw the opportunity to better leverage newer technology. Here we enter with RFID and TrakSYS. So let's discuss RFID systems first. RFID has been around for a long time. You know, Tim, why was it now a good option for this project?
Yeah, that's a great question, Corey. For Hydronautics, there were a couple of significant factors which made now the right time for us to implement a project like this using RFID. The first factor was the significant decrease in RFID tags as far as their cost goes compared to only a few years ago. The second factor was Hydronautics' recent investment in automation of our production equipment. So RFID is a much better fit than barcodes in an automated production environment. When we launched our RFID project, not everyone was familiar with how RFID works. So we went through an education process with everyone, explained the benefits and differences between RFID and barcodes. The passive tags can read from any orientation. So the ability to read tags from a distance without the need for line of sight is a huge benefit over barcodes for us, since they need to be read at a closer distance with line of sight. Quickly multiple tags on our filter elements at one time. We can quickly read those compared to when we're reading barcode labels at one at a time. And the tags hold valuable data for end users. Our tags hold both the electronic product code data for global identification, as well as customized user-defined data to meet our specific needs. Tags they're harder to damage and can be buried underneath a protective layer. Another significant benefit of RFID was that we were able to embed our tags underneath a fiberglass outer shell of our products and still be able to read the data. This allowed us to protect the RFID tag while barcode labels on the outside, they've been much easier to damage.
So Jim, can you bring us up to speed with what's happened with RFID since it was first introduced?
Sure. RFID technology has gone through a cycle similar to many other new technologies when they're first introduced. The Gartner Group actually developed a diagram of that and gave it that Gartner hype cycle that you're seeing on the screen. And what happens is a new technology comes out and the expectations are a little bit ahead of the implementation of that technology. In many cases, maybe the cost of the technology is higher than expected, or the interoperability of the technology between different vendors, or just the functionality of the hardware is not where it should be. So Walmart saw this back in 2003 when they made a requirement that all of their vendors' pallets would come into their facilities with RFID tags. And due to the cost and the complexities at that time with RFID technology, they ended up backing off of that and removing that requirement. But that was a long time ago, and what we're seeing now is, if you look at that diagram, we're over there at that plateau of productivity. So, some people got discouraged with it, but the basic good features of RFID were still there. The standards were developed, and as Tim mentioned, the cost of the tags came significantly down. And so we are seeing a lot of customers who are implementing this. We have implemented it a couple of times in food and beverage companies because of the FDA requirements of being able to do recalls very quickly. The traceability using RFID tags for that has been a big advantage for them. Also, other industries, say like the automotive, where there's a liability if things go bad and someone could get injured, it's become very critical for them. And finally, just customers like Hydronautics that saw how it was going to make their operations more efficient and embed a tag that their customer could use, so there was some extra value for their elements.
So the appropriate selection of the product identification method, whether it's barcode, RFID, or some other method, it should be carefully considered given the benefits and limitations of each of these technologies. The other key component of the solution was TrakSYS as the MOM platform for data collection, visualization, and integration with the RFID, ERP, and other business systems. So why did Polytron recommend TrakSYS, and what was the key functionality that TrakSYS provided?
Yes, TrakSYS is a very flexible system and can connect to disparate data sources and bring them in and integrate them and produce reports and dashboards and so forth with data from various sources. So you see there we're connecting TrakSYS up to JD Edwards to pull the information that it has and also pass information back and forth. We also have the RFID equipment that has specialized communication protocols and so forth that we were connecting to and getting this into TrakSYS, where we could display reports and allow interaction with the system from operators.
So you selected RFID and TrakSYS as the core components of the solution. Now you have to architect the components into a solution. How did all that work together to meet the Hydronautics project goals?
Yeah, so this slide is showing some pictures of the equipment that was used on this. And if we start in the upper left picture, that's a picture of a label printer that will print human readable labels that also have an embedded RFID tag. These were placed at the front of each of their process lines, and we would get information from JD Edwards as to what product they were producing, the serial number, and so forth, and it would automatically print an RFID tag to be applied to that particular filter as each one is started on the production line. Over to the right of that is a handheld RFID reader with a built-in touchscreen that allows an operator to interface with it and select different features, and display data from the RFID tags. On the left bottom, that's an example of the fixed position RFID reader that were positioned around the plant to read the filters as they were moved throughout the facility, and we put them in specific locations where we needed to read the filters without any operator intervention. To the right of that is shown an example of an antenna. It connects to that reader. That particular reader will handle up to 4 antennas. So in different configurations, we would have different antennas and readers and different gains on those in order to get the appropriate reads based upon the distance of the filters and how they were oriented. And finally, of course, we had TrakSYS to tie all this together and move data between these different pieces, and of course back to J.D. Edwards. This shows some examples of the handheld screen. So you notice that we have a easy to use, considering the small screen navigation method there, that they can do inventories or read individual filters or read a full palette of information. And we actually put the reader in different modes. So if you were reading a full palette, you wanted to read or doing an inventory situation, you'd want to read as many as you could all at the same time. So we put the reader in a higher power mode, and it could read at a longer distance and try to read as many as possible. Other times they wanted to look at one specific filter and read the data from it. So those center 2 pictures show reading the data and displaying the data that's actually on the filter. It doesn't need to go back to a database or anything to get that data that's stored on each of the filters. Or also, we did the same thing with palettes. So we put a palette ticket on there that could read and have some of the summary information, allow them to be able to sort palettes and send them to the right customer based upon some of the key performance values of those set of palettes. And here's another example of how we use TrakSYS. So at the top, you see there a reprint screen. So like I mentioned, the tags were automatically printed and applied to each of the filters, but sometimes things would happen with the printer. It might jam or run out of labels or something like that. And so this allowed the user to be able to select a specific serial number of a filter and reprint that label. And then below that shows an example of some typical report that would show what filters were going by a certain location for those fixed readers, so they could see the status and make sure that everything is reading properly and show what has happened at that particular location.
From my years of running manufacturing plants, I know physical inventory can be very disruptive to operations. Tim, can you describe your semi-annual inventory process and how the new RFID system saved time?
Sure. Our semi-annual inventory process involves taking a physical count of all of the inventory on our production floor, similar to the slide you saw earlier on the right-hand side. So production stops for the entire day, sometimes up to 2 days, and all the inventory gets placed into specific predefined locations throughout the production process. So we have approximately 10 to 12 locations in our ERP system for costing purposes. So production departments would then organize each area further by product family for easier counting, at least easier counting in a manual way. So once everything was organized on the floor, teams of operators would begin barcode scanning elements one at a time. So the process just of scanning itself took approximately 16 to 24 hours to complete. Once the count was completed, the physical inventory list would be compared to a JDE inventory report, and variances would be investigated as needed. So our RFID inventory application was developed to emulate this current process but much more efficiently using handheld RFID scanners. The first time savings was the eliminating the need to organize all the elements by product on the floor. So all we needed to do was to select the inventory locations from a top-down menu, use our handheld scanner, and the RFID application would automatically organize all that scan data into a pivot table format. Second time savings comes from the ability to scan a group of elements. We do these inventory counts. We're at about 10 to 15 feet from the set of elements. The third time savings comes from the automatic data upload from the RFID scanner to our RFID database and easy data exporting. So you saw the handheld reader that Jim had there. Once we scanned a whole set of elements, there's essentially a submit button that you push and it uploads the data. So our last RFID inventory count required only 2 people to scan the entire factory, and it took us about 3 hours to complete the process.
So Tim, did the project deliver the functionality Hydronautics was seeking?
Yes, our RFID project delivered the functionality that we were looking for. We established element traceability and the RFID application interface to our JD Edwards system. We have real-time dashboards and reports. Polytron, they helped to develop a real nice user interface for RFID handheld readers. A vital application from the project is that we have a platform to grow our RFID system into other areas of our business. And we have RFID fixed readers and antennas throughout the facility for tracking WIP, as well as handheld readers for inventory management. We actually have a brand new expanded warehouse that we're implementing, be loading all of our materials over into that building within the next month or two. So we'll be installing a new set of RFID fixed readers to read all the pallets and elements that come in through the receiving doors. So it's been a very big success for us.
And more importantly, the business benefits. Were the expected results achieved?
Yeah, I think the benefits of RFID to our business were definitely achieved, and they'll continue to expand for us going forward. We've had measurable ROI based on significant reduction in labor cost required to manually sort the products on the physical inventory processes that we go through. We've been able to complete plant-wide inventory reconciliation in about half the time that it previously took using the barcode scannings. And we have real-time visibility and product tracking. And it's also been great to see the RFID leverage to increase throughput at critical bottleneck equipment. We originally were counting only inventory on the factory floor, but once we start running into problems in the production processes themselves, we've started to look to the RFID technology to see if we can replace more laborious processes by simply reading the RFID tags. And we have a vital product information and quality data stored on each of the individual products, which has the opportunity to provide additional benefits to Hydronautics customers going forward. So there's a lot of integration and deployment work that we still have ongoing and investigating to try and leverage the technology pretty much around our company.
So thank you, Tim and Jim, for sharing your experience and how TrakSYS and RFID help to improve inventory management and traceability at Hydronautics. Today, we've seen a few ways how TrakSYS can connect to a variety of data sources to monitor production and inventory transactions in real time to provide an accurate traceability record. TrakSYS is a unified manufacturing operations management platform capable of delivering a variety of solutions that create a connected data flow and integrated view across the enterprise. So with that, we're going to jump into the Q&A portion of the webinar. Feel free to enter the questions into the webinar console. And in the interest of time, we'll only answer those questions that make sense to answer in a group setting. As a reminder, all questions will be addressed after the broadcast and emailed out along with a link to a recording of the webinar. So we have a question coming on the line. The first one is, I understand there are different types of RFID tags. Can you describe some of the different types and how you made your selection? Jim, can you take that question?
Sure. So yeah, there's different technology used in RFIDs and tags, and the two biggest categories are passive and active. So an active one would have a battery in it and so forth, but they're going to be a lot more expensive and not as small. So that was a natural to go to the passive type RFID tags. And then within that group, there's also various frequencies that the tags work at. In this case, we wanted one that would read from a pretty good range and have wide acceptance by compatibility. So there's a lot of vendors that make the tags that will read. So we chose ones that operate in the 900 megahertz range.
So another question, in implementing RFID, switching from barcode, did you run into any unexpected pitfalls? Tim, why don't you take this one, and maybe Jim even wants to jump in on the back end.
Sure. There were a couple things that we needed to address at the beginning of the project. We had to do some testing. One of them was the fact that the products we produce are round. So the application of the RFID tag to our product, we had some orientation factors that we had to consider. Whether did it run around the element a certain way? What was the placement up or on the top of the element, near the bottom or in the middle of the element? So some of that had to do with the process equipment that was going to be handling the elements. So we did some testing for readability and in different placements and orientations. So that was one of the factors that we had to take into account. Another one is the fact that RFID, it broadcasts its signal, doesn't, it's not directional like a barcode reader. So we had to find, especially when we're tracking the inventory through the factory floor, we had to identify specific locations that we were sure every element would pass through. So we had about 3 different areas that we identified would be a good place to put RFID readers. We have, for example, we have a curing oven where we roll carts. You saw the cart in the previous picture. Every element has to pass through that oven, so we placed RFID or RFID readers there. And then there was another section towards the back of the line before elements go through performance testing. There's specific conveyor ovens that they pass through. So we installed smaller readers and smaller antennas to read the elements one at a time. So those were kind of the main, a couple of the main factors we needed to take into account. Didn't realize it once until we got the readers in the factory and working within our environment and our process flow.
All right, well, we're going to wrap things up. Thank you to everyone who wrote in and to everyone that joined us here today. The answers to all the questions we received, not just the ones we covered, will be emailed out to you. For anything else, please feel free to contact us at the email address on the screen. You can also find out more about our platform, TrakSYS, on our website, www.parsec-corp.com/TrakSYS. Till next time, thanks again.